In this video, I'll teach you guys the inverse of a matrix and how exactly to go about the inverse of any matrix. I'm Nathaniel, and let's get started. So the inverse of a matrix. Before we start talking about inversion in matrix or inverse, let me show you something. What will I multiply by A to give 1? Notice that every time I multiply A or any number by its inverse or its reciprocal, like this, it will cancel out to give 1, right? So if I ask, what can I multiply with 2 to give 1? Easy, I can always multiply 2 with its inverse or its reciprocal. So 1 over 2, or the inverse, and this becomes 1. This cancels this, and this becomes 1, right? 1 in matrix, if you remember, is the unit, or the unit matrix, or the identity matrix. So in a 2 by 2, it will look like this: 1 1 0 0, right? So, and of course we can have this 1 over A. This 1 over A can be rewritten as A superscript raised to power minus 1, right? Indices. So this is a concept inverse. So anytime you see A raised to power a negative 1, they are referring to the inverse. So if I multiply A like this, multiplied by A inverse, which is what we are looking at now, we want to find its inverse, it's going to always equal to the identity 1, right? That's the concept. So now in this lesson, all we need to do is find this inverse. That's the concept of the inverse of a matrix. So every time we're asked to find the inverse of a matrix, just use this formula here: 1 over determinant. Just find the determinant of that matrix, 1 over determinant, multiplied by the adjoint of A. Don't worry, we'll explain this part very soon. So that's all. Once you find the adjoint, which is the only new part here, multiply by 1 over the determinant. That's all. So they'll ask you to find this now. What is the inverse of this matrix? So the first thing to do is to state the inverse formula. So we know that the inverse of a matrix is always going to be 1 over the determinant of this same A multiplied by the adjoint of A. So now all we need to do is find the determinant and A, now the adjoint of A. So let's go ahead and look for the determinant, and then we'll look for the adjoint of A. So very quickly now, let's find the determinant of A. Let's use the shortcut method, because no one will ask you for the longer cofactor method. They just go straight, because we have more important things to be doing. So no one will ask you for the cofactor method exactly. All they need is determinant. So we just say here that the determinant is equal to, since this is a 2 by 2, note that inverse determinants, they are always 2 by 2 or 3 by 3 square matrices. You won't find 3 by 1 or all that. They are always square matrices like this. So if they're asking you to find the determinant of a matrix that is not square, then it's not correct, it's not possible. So now the determinant of this is very easy. All we need to do, multiply the diagonals and subtract it from the multiplication of the second diagonal like this. 2 times 3 is what? 6. So multiply this 2 times 3 minus 1 times 4, which is 4. This is a shortcut method, and if you subtract 6 minus 2, that will be equal to 2. Very simple. So that's the answer for the determinant. So now we have determinant as 2. Can proceed now to find the adjoint of any matrix A. Now, simple. All you need to do is find the cofactors of this matrix. So I did a video on cofactors, so make sure you watch that. It's going to be in the description too. So all we need to do is find the cofactor of this matrix and then transpose it. Remember what I said about transpose? Just interchange the row and the column. So that's all we're going to do. So the first thing you need to do is to find the cofactors of this matrix A. So let's go ahead and find the cofactors first for transposing it to get the adjoint. So this is a 2 by 2 matrix, and very easy to find the cofactor. All we need to do, like I said, label them first. So all we need to do is just label this matrix here. So let me just go ahead and label it here. So A11 is 3, 2, 2. Very simple. Now I have named them. Now every single thing is going to be easy now. So now to find the cofactor and the minor, all I need to do, first of all, I need the sign first. So this 3, I'm dealing with 3 first. So minus 1, all raised to power what? What is the position or the name of this matrix here is A11. So 1 plus 1, 1 plus 1 is 2. So the sign is going to be minus 1 raised to power 2. And minus 1 raised to power 2 is just 1. So we have plus 1, but what is the minor? To find the minor, all we need to do is to delete the row and column associated with this matrix. I'm not going to go in depth in this because I already talked about this in depth in the video I made on cofactor and minor specifically. So make sure you go check that out before watching this video. So delete the row and the column, and you're left with just 2. So put 2 here, and then we can move on to the next one. Or we can just multiply straight. So 2 times 1 is 2. So this place here is 2. So the cofactor here is just 2. Now let's go ahead to find the second one. So now second one, like I said, first thing to do is to find the sign by default minus 1, all raised to power the position 1 plus 2, which is 3. And of course, minus 1 all raised to power 3 is minus 1. Right? So we have minus 1. So this sign here is minus 1. Or alternatively, even if you don't want to use the position, you can just label this like this: plus, minus, minus, plus. You want to use this pattern so that nothing repeats. Plus, minus, not plus plus, but plus, minus, and plus, minus, no plus plus. Everything doesn't repeat except from the diagonals. So we'll have plus plus here and minus minus here. So that's the pattern. So I know that here this 4 is going to have a minus here for the minus sign. Like I said, the first thing we need to do is to find the signs for the minor before knowing the cofactor of the minor. So, but we can use this as a guide. I know my sign here is minus 1. I know my sign here is minus 1, and I know my sign here is plus 1. So I don't have to go through the process of using this one. So now all I need to do is find the minor and for this, and find the minor for this, and multiply to find the cofactor. So now what is the minor for this 4 here? Like I said, delete the row and column associated. So delete this and delete this. What's left? Just 1. So this is 1. Multiply minus 1 times 1. That's the cofactor, which is minus 1. So this part is minus 1. That's the final answer. That's the cofactor. So now I have the sign for this already. So now all I need to do is find the minor for this one. So all I need to do is delete the row and the column associated with it. Delete this and this. I was left just 4. So I have 4 here. Just multiply to get the cofactor, which is minus 4. Now the next one, to find the sign, I already have my sign here plus 1. So no one's going to ask me for the workings in total. So I can just go ahead plus 1. I already know my sign is plus 1. Now what is the minor for these 2? All I need to do, delete the row and the column associated with these 2. Now what's left? 3. And then multiply to get the cofactor, which is plus 3. Plus 3 here. Very simple. And you can see how the position will help us, and or you can use this pattern to mimic the whole thing. So plus, minus, minus, plus, just like here. Plus, minus, minus, plus. If it doesn't look like this, then it's something is very, very wrong. So now I have gotten my cofactors, but my question is the adjoint, and the adjoint is just the cofactor of the matrix when transposed. So now that I have the cofactors, now let us transpose it to get the adjoint. All I need to do is turn this row into column, turn this row into column. So now turn this first row into column. That will be 2 and minus 1, right? That's the first step. Now the second step is turn this second row into column. So the adjoint is just find the cofactor. This is the cofactor, and then transpose the cofactor. That will give us our adjoint. Very simple. So as you can see, now I have my determinant, which is 2 of this matrix, and I have my adjoint of A. Now the inverse, as you can see very clearly, now will just be what? 1 over this guy, which is 2, multiplied by the adjoint. This is the adjoint, so just multiply it like this. So we'll have 2 minus 4, just copying this here, minus 1, 3, like this. I can go ahead and just delete this part. That's our answer, very simple. You can leave it like this, or 1 over 2 multiplied by minus 4, that will be minus 2. 1 over 2 multiplied by minus 1, that will be minus 1 over 2. And 1 over 2 multiplied by 3, that will be 3 over 2. So you can leave your answer like this, still the same thing. Or you could leave your answer like this, just 1 over 2 multiplied by this. Or you can multiply them to bring them out like this. Very simple. Or you can simply say like this. You can just put the 2 under like this. Still the same thing, still the same outcome. So that's the inverse of this 2 by 2. How about 3 by 3?